The next topic we're going to look at for vectors are what are called unit vectors. So these are vectors that have a magnitude of 1, and two really important unit vectors that we use are the unit vectors along the positive x and the positive y axis. I has a component form of 1, 0, and j has a component form of 0, 1. We're also going to be looking at what are called directed unit vectors. To find a directed unit vector, you take the vector, each piece of the component form, so the x component and the y component, and you divide them by the magnitude of the vector. So that will scale it down to a unit vector, but it will be heading in the same direction as the initial vector. Starting off with some basics with unit vectors, we have -3i and 4j. So in order to sketch that, we need to remember that I has the component form 1, 0, and j has the component form 0, 1. So essentially what we're giving you is the component form of the vector, just in a different way, using the unit vectors instead of just saying -3, 4. So to sketch -3, 4, we go left 3 and up 4. When you're given the initial point and the terminal point of a vector, to rewrite it in terms of I and j, you simply find the component form and then work backwards. Remember, component form is change in x and change in y. Our component form ends up -3, 8. Writing this in terms of I and j, we have -3i plus 8j. Multiplication and subtraction with I and j is very similar to multiplication and subtraction with variables. We'll distribute our multiplication and then combine our like terms. 2 times -3i plus 8j minus 3 times 2i minus j. We get -6i plus 16j minus 6i plus 3j. Combining our like terms, we end up with -12i plus 19j. Directed unit vectors are where we take the vector and divide each component by its magnitude. We'll start off by finding the magnitude of v, which is using the distance formula. When the vector is in component form, it means the initial point is 0, 0. So we can simply take each piece of the component form and square it in order to get our magnitude. -2 squared is 4, plus 25 gives us a square root of 29 for our magnitude. The unit vector in the direction of v will be -2 divided by the square root of 29 and 5 divided by the square root of 29. Of course, we can't leave a square root in the denominator, so we will rationalize by bringing that square root of 29 to the numerator, dropping the radical in the denominator. Same thing for our y component. This last one is asking us to find the component form of a vector given its magnitude and knowing its direction. The first step is to find the magnitude of the direction, and then we'll figure out the scalar multiple that we will need to give it the correct magnitude. I'm going to call this vector u because it doesn't have a name, so we're first finding the magnitude of u. Distance formula again, we get to simply square each component of our vector and add them together. This gives us a magnitude of 9 plus 36, which is 45. 45 can be simplified because 9 is a perfect square factor. Square root of 9 gives us 3, and 9 times 5 gives us 45, so that 5 is left over. To find our v vector, we then take the component that we were given and multiply it by a scalar of the magnitude we want over the magnitude that we have. We can either distribute and then rationalize, or we can rationalize and then distribute. If we rationalize first, we only have to rationalize once instead of twice. After we distribute, we'll have two pieces with a radical in the denominator. To rationalize when there are two pieces in the denominator, you just move the piece with the radical. The 3 can stay in the denominator because the 3 does not have a square root attached to it. So just simply move that square root of 5 up and drop the radical on the 5 in the denominator. I can simplify before I distribute that 10 and the 5 have a common factor. My new scalar is 2 times the square root of 5 over 3. And finally, I will distribute to each piece in my component form. I'm going to write the 2 times the negative 3 because I see that that will cancel with my 3 in the denominator. So instead of multiplying them and then dividing, I'm going to just cancel those all together. The 6 will simplify with the 3 as well, but I can either multiply first and then divide, or divide and then multiply. Since order doesn't matter, I'm going to go ahead and multiply my 2 by 6. And finally, simplifying each piece, the 3's cancel here, so I'm left with negative 2 times the square root of 5. Over here, 12 divided by 3 gives me 4 times the square root of 5. That gives us the component form of the vector that's heading in the same direction as the u vector with the correct magnitude. We have 2 U-try problems to start us off in class tomorrow.